Good morning, everyone. So today we are going to go through a few questions to review for preparing for the midterm. The midterm is on November 23rd from 8:30 to 11:30. Also next week on the class on Monday, I will also go through these review questions. So in order to make our time, your time and my time effective, I encourage you during this weekend to go through the solution of all these posted problems. And in this case, we can discuss the solution on Monday. So if you can, please go through the questions during this weekend, tomorrow and after tomorrow. And on Monday, when I go through the solution, you can compare your method or your answers with the method that I'm using to answer the question in the class. I will not go through the complete solution for each question. I will just maybe go through hints, how we can approach it and how we can solve the question. So I will leave it to you to go through the complete solution. So I will help you if you have any questions during the class of Monday or Tuesday. I'll be able to provide an answer to your questions if you have any problems. So this question here is about air conditioning for cooling for summertime. A commercial building is as shown in figure 2 is 10 feet high. The outside summer design temperatures and humidity ratio are the outside temperature 100%, 100 Fahrenheit, and the humidity ratio is 0.002. The inside temperatures 78. So we are given only the inside temperature. The building is exposed to outside from all directions. The heating gain through walls, windows, doors is given 60,000 BTU per hour. The relative humidity of the air after the adiabatic humidifier is equal to 70%. Because of the fan, the supply air temperature increased by 3 degrees. So assume that there is no infiltration and calculate the design cooling load. So the cooling load in this case, so it's very important to understand the component of the heating load and the cooling load. So in the question, in the exam, there will be a question related to similar to this. And in that question, in order to be able to solve it, you need to make sure that you understand the components of the heating load and cooling load, the sensible components and the latent components. In this case, we are given the heat gain through the building construction, windows, doors, walls, roof. So what we need to add the load from people, from light, and from equipment. Infiltration here is given equal to 0. So there is no infiltration. That means the building is set at higher pressure than surrounding. That means this building is pressurized. That's why there is no infiltration. So we need first to find the cooling load. As I said, I will not go through all the numbers. I will go through the method, how we approach the solution. And I will leave it to you to add all these numbers and come up with the final psychrometric chart. So I will just maybe go through only the solution in terms of equations. So QS for the building equal to Q structure, building structure, plus Q for people, QS, plus QS infiltration, plus QS equipment. And also plus Q light. So this is the total sensible cooling load. QL So we mainly have QL from two components, from people and from infiltration. So QL people plus QL infiltration. So, excuse me? Yes, QL also possibly from equipment, yes. Also QL from equipment. We are given equipment here and so when we find the cooling load in terms of QS and QL, what we can do to complete the solution of this question, we have to come up with the cyclometer chart. So the outside air was 100%, 100 Fahrenheit and 002 relative humidity. So the outside air, this is point number O. I'll just follow the exact, yeah. So the air, it's 100% fresh air, so there is no return air. The air goes through filter and it goes through air washer. The air washer is a adiabatic humidifier that uses water for humidification. So that means the air will leave at higher humidity and lower temperature. And in this case, the air washer was able to reduce the temperature by 20 degrees. So the relative humidity of the air after the adiabatic humidifier is equal to 70%. So what does that mean? We have to draw humidification line. It will intersect with relative humidity equal to 70%. And that is point number 2. So the fan add thermal effect and increase the temperature of the supply air by 3 degrees. So from 2 to 3, the temperature will increase by 3 degrees. From 2 to 3, the temperature increase by 3 degrees. The inside temperature is 78, but we don't know the another parameter to find out the exact location for the inside temperature. So in this case, what do we have to do? We have the cooling load and we have the inside temperature. So in this case, because we know QS and QL, we can find SHF equal to QS divided by QS plus QL. And that will be a certain value. So if we go to the cyclical chart now and we draw SHF, then we can draw a parallel line. That line will intersect with the temperature equal to 78. So that means we can find out point number 4. So as soon as you produce the cyclometer chart, now the other questions are supposed to be very easy. It's just like direct application for the equations, MC delta T or M delta W for the mass flow rate of the water. So now we draw the cyclometer chart and we need to find out the amount of supply air. So I think all the other questions are easy. The amount of supply air equal to, we know QS for the cooling load. And we know the T3 and T4. So that means QS equal to M multiplied by 0.24, which is the specific heat for air, multiplied by T4 minus T3. Or we can write Q total equal to mass flow rate multiplied by H4 minus H3. And any of these equations will give you M. So now we need to find out the flow rate of the water in the adiabatic humidifier. So the air enters the humidifier at 0.0 and leaves at 0.2. So we have W O, and we have also W2. So in this case, MW equal MA multiplied by W2 minus W0. So we know both W's, and we know the mass flow rate of the air, MA. The third question is about heat recovery. Discuss the effect of adding heat recovery, similar to figure number 2. We add heat recovery in order to reduce the amount of energy that you spend to cool the air. So the air will leave at 78 Fahrenheit and it will come at 100 Fahrenheit. That's why we are able to retrieve or recover part of this heat and move to this side in order to be able to reduce the temperature of the fresh air. So after adding the heat recovery, draw the air process of the system with the heat recovery on the cyclotic chart. Assume that the temperature T1 after the heat recovery is equal to 95. So we are able to reduce the temperature from 100 Fahrenheit to 95 Fahrenheit because of the heat recovery. And assume that phi 2 also, the relative humidity at point number 2 is 70. So the relative humidity for point number 2 also does not change. So on the same cyclotic chart, I will draw the process using the red color. So the heat recovery will be able to change the temperature from 100 to 95. And then we have humidification for point number 2. And we have 3 degrees temperature change. And then we have SHF. So you'll find the process will be shifted to the left side, and the location of number 4 or the room air will also change. So we have lower humidity because of this heat recovery. So discuss the effect of adding heat recovery between the exhaust. Okay. So now when we add heat recovery, we need to look at what are the things that change in our system. So previously, when we have no heat recovery, we calculated the amount of airflow, the amount of water, and also we find out the location of point number 4 in the chart. By adding heat recovery, you'll find that you need to supply less air because this point here, point number 3, the new location, point number 3. So T3, I'll call it T3 prime after this modification is less than T3. That means this value is higher and this is the same and the mass flow rate will be less. So that means we have to provide less flow rate. So the benefit of adding the heat recovery in this case will be able to reduce the fan capacity and reduce the amount of supply air to the space because we have higher temperature difference between inside and supply. In terms of also water consumption, W2 prime is less. That means we have to provide less amount of water for humidification. So the benefit of adding the heat recovery, we are able to reduce the amount of water for humidification and reduce the size of the fan. That's for this question. Any question about this example? If there are no questions, I'll move to the second example. So in this example here, we have space at sea level, and it is to be maintained at 75 Fahrenheit and 50% humidity. We are using also again 100% fresh air, and the temperature of the fresh air is 110 Fahrenheit and relative humidity equal to 20%. So the fresh air is going through heat recovery unit, which uses the return air to cool the fresh air before a draw off this air as shown in the figure. So we have a fresh air coming, it goes through heat recovery, and then it leaves at lower temperature, then it goes to the air handling unit. So we are using the cold exhaust air in order to cool down the fresh air so that you can save some energy. The surface temperature of the cooling coil is equal to 50 Fahrenheit and it delivers air to the space at 60 Fahrenheit. So we know the supply air temperature and also we know the surface temperature of the cooling coil. Draw the process of the cyclomatic chart. So we have the inside 75 and 50%, 75 and 50%. The outside 110 and 20%. The outside is 100% and 20%. If you look at the relative location of these points, it will be almost on the same horizontal line, approximately. So this is O, and this is number 3. Sorry, 4. So the heat recovery will reduce the fresh air temperature by 20 degrees. So it will leave at 110 minus 20, it will be 90 Fahrenheit. So 90 Fahrenheit. So this is point number 1, 2. So after the air leaves the heat recovery, it goes through filter and goes through cooling coil. So the air will leave the cooling coil, or the surface temperature of the cooling coil is equal to 50 Fahrenheit, and the air will be supplied to the space at 60 Fahrenheit. So now, Fahrenheit. I'm just trying to draw the change the location a little bit in the chart in order to make sure that the final drawing is as close as possible to your solution when you use the actual segmented chart, because the location of the point in the chart will make difference in your solution. So the air will leave the yes. For which question? For point number 4? This question here? For point number 4, the place is maintained at 75 Fahrenheit and 50% humidity. So we are given the information for point number 4, because the air will leave the space at the similar to the inside condition of the space. So that means point number 4 is 75 and 50%. That's why we were able to locate point number 4 in the chart. So we have the cooling line. It will intersect with the 100% at 50 Fahrenheit, which is the ADP. And the air will be supplied to the space at temperature equal to 60 Fahrenheit. So this is the supply to the space. So that means we can supply air to the space by drawing the air conditioning line. So that's the complete cyclic chart for this question. What is the off coil relative humidity, and what is the wet bulb temperature of the fresh air leaving the heat recovery? So we need to find the relative humidity for point number 3. Point number 3 is this point. It's directly, we can read this from the chart. So we know the location point number 3, and we can find out phi 3 from the chart. What is the wet bulb temperature of the fresh air leaving the heat recovery? So the fresh air leaving the heat recovery is point number 2. We need to find out CW. And again, we can read this from the chart. So this is supposed to be an easy question. How much heat was removed by the cooling coil per unit mass of dry air? So that means we need to find out how much heat was removed for each 1 pound of air. And it is equal to H2 minus H3. So for question number F, Q equal to H2 minus H3. And that will be BTU per pound per BTU per hour per pound. Because we are doing the calculation for 1 pound. Yes. BTU pound per hour.
Because the H value.
Yes, BTU per hour. Yes, you are right. Yeah. So it will be BTU per hour for 1 pound of airflow. BTU per pound? Yes, BTU per pound, yes. You are right. BTU per pound. Sorry for this. So when we multiply this by the mass flow rate, it will be the total cooling capacity. So for number G, how much energy was saved by using the heat recovery unit per unit mass flow air? How much energy was saved by using the heat recovery unit per unit mass flow air? So where we are saving energy is it's in this location here. So G Q saving equal to H1 minus H2. So we are saving energy by adding heat recovery, and by doing this, we are reducing the temperature from 110 to 90 Fahrenheit. So H1 minus H2 is the amount of energy saved by adding the heat recovery. What is the mass flow rate of the condensed water from the cooling coil per unit mass flow rate of dry air? Again, so in this case, we have cooling coil that change the temperature from this point to this point, and also change the humidity from this level to this level. So if we draw a horizontal line, that is W3, and this is W1, W2, H, MW equal to W2 minus W3. Any question about this example? So in the exam, there will be 3 questions. One is related to heat transfer. One is related to psychrometric chart, similar to these 2 that we solved previously. Most probably it will be similar to this one, some related to heating load, cooling load. And third question will be similar to this one. So this is a design question where you have to design an air system that satisfies your requirements. So I'll go quickly through this example. The inside conditions of space are T dry equal to 77 Fahrenheit and relative humidity 50%. And the outside conditions during the cooling season are 90 Fahrenheit and 10%. So it is a summertime, high temperature outside and lower humidity. Similar to figure 4. Plot the inside and outside conditions of the cyclomatic chart. If you know that the sensible cooling load inside the space is equal to 100,000 and SHF equal to 0.8, suggest an economical air handling unit that will be able to maintain the inside conditions. And that means we need to specify the component of the air handling unit, maybe filter of fan, heating coil, cooling coil, humidification, and any other component that we need to include in the design of the edge air handling unit. And then we need to calculate the airflow and the capacities of the components of the air handling unit. So we need to suggest an air handling unit, and then we size the component of this air handling unit. The first step is to draw the cyclomatic chart. So the outside, 90 Fahrenheit and 10%. 90 Fahrenheit and 10%. This is point number 0, the outside. The inside is 77 and 50%. 77 and 50%. So I can call this point R, room temperature, R. So we are using fresh air 100%. So there's no return air. We are using 100% fresh air. And also we know the QS of the space, the sensible load of the space, and also SHF. So QS equal to 100,000 BTU per hour, and SHF equal to 0.8. So how do we size, or how do we design an air handling unit that will be able to satisfy this situation? Yeah. Since this point is dry and hot weather, most probably I think an adiabatic humidifier will be a good solution for this question. Because if we allow the air to go through a adiabatic humidifier, it will leave at lower temperature and higher humidity, and then we can supply the air to the space to satisfy the cooling conditions. So that means if we have a space, this is the exhaust air from the space. We can have fresh air coming to the air handling unit, and we can have adiabatic humidifier. And then we have a fan that will be able to supply the air to the space. And of course, we have to install also filter. So if we choose a system like this, very simple adiabatic humidifier with a fan and filter, most probably I think we'll be able to satisfy the design conditions of the space. So to simulate this in the second chart, if we allow the outside air to go through adiabatic humidifier, it will leave or it will follow constant enthalpy line. Since we know SHF of the space, SHF equal to 0.8, then we can draw parallel line, and that will be the supply air temperature and humidity to the space. Since we located point S on the chart, now we can size all the equipment. So if we agree that we will have water humidifier and a fan, we need to size these two components. We need to find out the mass flow rate of the water, MW, and the mass flow rate of the air. So the mass flow rate of the air, MA, equal QS divided by 0.24 multiplied by TR minus TS. The mass flow rate of water equal to the mass flow rate of air multiplied by WS minus WO. And then we can, that's how we can size the air handling unit. So the location of the point outside air, outside, and room for this question here is very important. If O was located here, the solution might be totally different. So that's why you need to draw the point on the chart first, and you think about the proper process that you have to follow in order to reach or to supply air to the space. So in summer condition, we need to supply the air at lower temperature. In winter condition, we need to supply the air at higher temperature. So you need to find out, or first keep in your mind, is it summertime or winter time? And also the location of the point on the chart. Based on those, you can decide what is the proper air handling unit that you need to design for your question. So I'll stop here today. We'll continue on Monday. Go through the whole solution for all the questions provided to you in this document, and we'll continue solving a few other questions from this document and also questions related to heat transfer. So on Monday we'll solve questions related to heat transfer, and also we'll continue the solution of these documents. Yes. In winter condition, you have to know a property of the outside air, the property of the inside air, locate them in the chart, and then from there you can think about the solution. So I think there is one question here related to winter conditions. If there is no questions, I will maybe add one, and then we can discuss it in the class, because it needs discussion. You have to think about it. For example, if the outside air was here in winter conditions, we need to reach room temperature. So in order to reach the room temperature, we have to heat the air, maybe humidify it, and supply to the space. Because we need to supply the air at higher temperature to the space. For example, this is one solution. If the outside air was somewhere in this location where the humidity is very high, in this case, you may need to dehumidify and then supply the air and heat it. So that's why the location of point number O in the chart, the relative location of the inside conditions and the outside conditions in the chart will help you to find out what is the proper air handling unit that can be chosen for this question. Yes. The exam is 23rd of November from 8:30 to 11:30. I will add announcement to the course website so that everybody will know about this. What kind of? So the exam, I'll upload the exam to the course website. You can download it. You need printer. you need access to internet. And then you have to provide a manual solution. So you have to solve the question, then you scan it and upload it to the course website. Yeah.
Where can students find more practical question of interest?
Where?
Where can the students find more practical question of interest?
Of heat transfer. The book has good questions. I think if you go to the chapter number 5 in the textbook, there are good questions at the back of the textbook. And also, I already posted 2 midterms in addition to this example. We'll go also through a few examples on Monday, on Tuesday.
What about second assignment?
The assignment?
Yeah, second assignment.
Yes.
Is there any update for second assignment?
So we may cancel the second assignment. I will not add the second assignment. So we have only one assignment related to psychometric chart, and there is no second assignment.
Where the students can find the lab manual?
The lab manual. So for the students who are scheduled the time to come to meet the TA, the TA will provide hard copy of the lab manual and also the psychometric chart. So you have all the documents ready for you to do the lab. And I will upload the lab manual and also the video for the lab for all the students who are doing the lab online, especially for the graduate students. And I know there's one group from undergrad who are doing this online, and they have the permission to do that from the university. So I'll upload the lab manual and also the video for the lab. Yes.
Is there any pre-lab?
Preparation for the lab? No pre-lab, because it is 100% to psychometric chart. So it's similar to what we are doing in the class right now. Yeah. So you take some measurement for the temperature before the heater or after the heater, and then you have to do and also there's a humidifier, and then you have to do some calculation. Yeah. If there's no more questions, I will see you on Monday. Have a nice weekend. There will be accommodation for anybody who needs accommodation, but please contact me in order to find out how I can prepare this accommodation or offer this accommodation. For undergrad, the accommodation will be done while you are in the class. So if there's accommodation needed for undergrad students, in this case, you need to attend to write the exam in the class, and then we can find the proper accommodation. Yes.
What about the foundation stuff? So I get extra time and all that stuff. So would I have to write the exam in person?